If we now go through an entire endodontic treatment, it will start with catheterization and shaping of the access paths. But before that, we have to analyze the treatments we want to perform radiographically. And for this, it will be necessary to use two X-rays, sun-centered, to analyze and understand the endodontic anatomy. For example, on this mandibular molar, we have two mesial canals that are quite distinct, visibly so on this X-ray, but we have more doubts about the anatomy of the distal root. Is it a bifurcation? Is it a miss of these two canals? And only the off-centered X-ray will be able to provide information on these kinds of things. So thanks to these X-rays, we need to identify difficulties and peculiarities that may arise at the level of curvatures or mineralizations, which may result in Schilder's triangles at the canal entries
or other issues,
specifically speaking. And finally, or we can analyze the integrity of the apical area. Is it resorbed? Is it intact? And this will help us anticipate all the difficulties we will encounter until reaching the working length. And this working length must be estimated on this initial X-ray. Now, it's true that it's very easy since we have many things that are digital and the measurements are very precise as long as we have an isometric technique when taking the X-ray. It's clear that the catheterization will be done once the rubber dam is placed and access paths are completed. To illustrate my point, throughout this presentation, you will see this maxillary molar that requires endodontic treatment because it's at a stage of chronic pulpitis. Once the rubber dam is placed and the area disinfected, it will be possible to create the access path to the canal, access path to the pulp chamber, removal of sulfurites if needed. The pulp roof connects to the pulp floor, making it particularly difficult. You can't even see or can barely see the radicular paths. So it's a particularly complex case. Once we've opened these access paths, we will be able to check this access path here with a micro opener and determine where the canal entries are. Do our first penetration, which we'll call the initial penetration. This initial penetration will require an initial irrigation, which from the start will be done with sodium hypochlorite to work in particularly aseptic conditions. This initial penetration will be done with size 8 or 10 files. It will allow us to detect high constraints. These high constraints, when they exist, will prevent us from going directly towards the apical constriction, but we will be able to detect them. When they exist, we will need to remove them. Here, in our clinical case, look, we will go down with a size 10 file. This size 10 file will not reach the length we estimated on the X-ray, so we will work with an initial working length as a safety measure, and we know that this length brings us closer to the apical target, as you see on the left X-ray. Sometimes the constraints are lower, and we can directly reach the apical third with a size 10K file. In some cases, we might be able to achieve apical patency right from the start. And from the beginning, we can determine the working length with electronic measurement and confirmed by X-ray. Here, in our clinical case, you see the descent of a size 15 file, a confirmation using an electronic apex locator of apex, and our validation of this length will guide us throughout the treatment, although we might check it again during the treatment, right after removing the initial constraints.